everyone, my name is Nur Alia binti Hassan Bakri, MH10963, and my group members Muhammad Tariq Nazmi bin Abdul Rahman, MH10955, Fazrul Hassani bin Kamaruzzaman, MH10958, Falik bin Muhammad Nur Hisham, MH10959, and Nur Fadila binti Hussein, MH10962. So today we are going to present about our project report for subject BMA 2623, Automotive Design and Styling, which is Perdua Besa 2020.
Hi, my name is Muhammad Tariq Nazmi bin Abdul Rahman, and I will present to you about Introduction Company. Starlight brand was established in 1998 February as part of the automotive business venture under the company Starlight Sendirian Berhad. Formed by a group of 5 friends, has the vision in becoming the market leader in the automotive after-sales industry. Starlight is expected to become the largest manufacturer of compact cars in Southeast Asia.
Hello everyone, my name is Nur Fadila binti Hussein. Today I'm going to talk about the main objective of the company. First, become the largest manufacturer of automobile. Second one is optimizing customers' needs and satisfaction. Next, achieving financial success. And the last one is increasing sales figure.
Company organizational chart. Muhammad Tariq Nazmi bin Abdul Rahman as Executive Chairman, Fazrul Hassani bin Kamaruzzaman as Director of Product Engineering, Falik bin Muhammad Nur Hisham as Director of Vehicle Engineering, Nur Fadilah binti Hussein as Director of Styling, Nur Alia binti Hassan Bakri as Director of ICT and Development. Vehicle Development Organization. Muhammad Tariq Nazmi as Executive Chairman, Fazrul Hassani as Director of Product Engineering. Under Product Engineering, there consists of Body Engineering, Chassis Engineering, Powertrain Engineering, Electrical Engineering. Then Falik as Director of Vehicle Engineering. Under the Vehicle Engineering consists of Package Engineering, Safety Engineering, Vehicle Dynamic, Vehicle Durability, Vehicle Thermal and Aero, Prototype, Planning and Test. Thirdly, Nur Fadila as Director of Styling. In styling consists of 3: exterior styling, interior styling, and modeling. And lastly, Nur Alia as Director of ICT and Development. The ICT consists of administrator, networking, and shop floor or development.
For methodology of the production, discussion is the first stage of car manufacturing for our company. In this stage, we will gather all the information regarding car design, testing, supply, demand, safety, cost, and others. In this discussion, we can divide into several categories such as information, production, and sales. These 3 categories are very important for us to make decisions in producing new cars. For the first category, we will take the result in this category that will be presented to us. It includes demand by community interest, study area economy, population or target buyers, supply, and everything related to our study area. Then for the second category, which is production, we collect information regarding production such as design, safety, testing, materials, cost per part, and others. This is very important to ensure that the costs provided are used as best as possible to produce a quality car. Other than that, we can identify if there are excessive costs used. Lastly, the sales category. In this category, we collect information regarding sales such as marketing strategies, advertising, promotional costs, sponsors, and others. That information is important to calculate the net profit for each car unit produced by our company. Production is the second stage of car production in our company. This stage is implementation stage. In this implementation, we divide it into 4 categories, which is prototype construction, prototype testing, first unit construction, or in other words, real car construction, and finally real car testing. These 4 categories are very important to make sure that the cars we produce are in good quality and safety, and if there is a failure in any categories, we will repeat the first stage of the discussion. With these steps, we can find a solution to every problem we face. Sales is the last stage for our company's car production. In this stage, we will focus on the best sales and advertising method to sell cars produced by our company. The same steps will be taken if there is a failure in the sales. We will repeat it from the first stage, which is discussion, to get the best solution to the failure.
Methodology of design. First one, this bezel-based model got a silver grille instead of chrome. No front fog lamp and smaller 14-inch wheels. Okay. The good thing is bezel now get a wing mirror mounted signal indicator as a standard. And then ESP as an electronic stability program is now fitted to 1.3 model as a standard. And then this 1.3 AV adds on a leather wrapped steering wheels and seats. Also a latest active safety suite, Advanced Safety Assist or ASA 2.0, the system which includes the Automotive emergency braking, can now warn customer of objects ahead at up to 100 km/h. Develop the prototype. The next step consists in fleshing out their original ideas by displaying them into the real world. To do so, our engineers carve scale models, usually using a type of clay called industrial plasticine. Eventually, a full-size model is carved to translate the look and feel of what will become the final design. Each prototype can cost more than 100,000 ringgit Malaysia because of the many parts, and the prototype themselves are handmade and highly customized. The parts needed often require months of lead time, which constrain when vehicle builds can start. The next step after the prototype is we are testing the vehicle. The first one, the Starlight Test Planning Group of the Vehicle Development Division will conduct tests at pre-production of each vehicle program to ensure the vehicles to meet all the requirements by the time which they reach the production phase. That, combined with inflexible deadlines for completing tests on those prototypes, introduce significant time pressure and unavoidable and challenging reality. To develop a test plan with tight schedules that combine multiple tests on vehicle to fully utilize all available time is most efficient ways. Then, there are many challenges that need to be overcome in implementing this approach, including complex compatibility, relationship between the test and destructive nature. Example, crash test.
As for competitors, we choose Proton Saga. The third generation Proton Saga is an A-segment saloon engineered by Malaysian automobile manufacturer Proton. It was launched on 28 September 2016 as the successor to the second generation Proton Saga. The third generation Proton Saga is based on the outgoing Saga FLX platform and is powered by Iris 1.3-liter VVT engine. Proton has completely re-engineered the exterior design of the new Saga. Its interior has been revamped and refined with an emphasis on NVH reduction. The third generation Saga is positioned as Proton entry-level sedan, below the larger B-segment Persona. Safety standards have been improved with the introduction of Electronic Stability Control ESC and a 20% stronger body structure. ASEAN NCAP has awarded a 4-star safety rating for the new Saga.
Hi, my name is Fazrul Hassani bin Kamaruzaman, metric number MH19058. I will continue to present about technical specification for Beza 2020. As you can see, that a lot of these specifications are identical to each other except for the curve weight. The curve weight is a little bit different from the G model to the X and X1 model, which is 75 kg. These two models, G auto transmissions and manual transmissions, are using key with integrated remote, while X and advanced model are using smart key. The other specifications are quite the same with each others. Moving on to the interior design specifications. So, in Beza 2020, semi-bucket leather seats are introduced. This Beza also equipped with a multimedia system with navigations. Also, the new meter combination and push start button was introduced. Next is luggage space. The new Pro2 Beza luggage capacity is 508 liters, and this model is also equipped with a handphone slot and USB port for cars users. Next is exterior design. The exterior design consists of several major parts. As we can see, the front design bumper is joined by the LED headlamp alongside the new hexagonal shapes grille, which is glossy black and silver finish for G model, while glossy black and chrome finish for X and advanced model. The rear bumper, we can see that the bumper has been revised, which is a deeper skirt that better covers the underside of the car. This fore model is equipped with two-tone side skirting and 15-inch two-tone alloys rims for X and advanced model, while 14-inch alloy rims for G model. In addition, this fore model has an electric side mirror which is retractable for X and advanced models. Next, I will explain about Beza safety features. This Beza is 5-star ancient NCAP rating and was equipped with safety feature which is Advanced Safety Assist 2.0, Vehicle Stability Control, Traction Control, Hill Start Assist, Anti-lock braking system with electronic brake distributions, seat belt reminder for driver and front passenger for advanced model, and one touch function with jam protection on driver sides. Powertrain systems. The standard G model is powered by 1 KRVE engine type 3-cylinder which produces 67 horsepower at 6000 RPM, while the X and Advance are powered by 1 NRVE 4-cylinder which is capable of 94 horsepower at 6000 RPM. The 1 NRVE is an evolution of the K3VE engine from the Pro2 Myvi. So, both engines are equipped with feature variable valve timing with intelligence, that is VVTI. The 1 KRVE engine type is equipped with variable valve timing with intelligence, while the 1 NRVE engine is equipped with dual variable timing with intelligence. Next is the design of the brake systems. The first is an anti-lock braking system with electronic brake distributions. The anti-lock braking system decreases wheel slip during braking and offers good lateral braking stability and a shorter braking distance. The distribution of electronic brake force is a kind of subsystem that adds ABS-equipped braking device functions. In the case of braking, EBD balances every wheel's effective floor braking force before ABS action all the time, which could effectively avoid wiping and swinging and decrease automobile braking distance. The second is Vehicle Stability Control. The VSC system is a relatively new, active safety concept introduced in emergency conditions to control vehicle lateral and yaw motions. From driver behavior, the desired vehicle motion is inferred. Then, control action is applied to regulate the movement of the vehicle under certain stability constraints to meet the desired motions. Another design of brake system is traction control. A slip control subsystem and a directional stability subsystems are part of the traction control system. By maintaining the slip ratio within an acceptable range, the slip controller can improve traction efficiency. Next is brake assist. In Pro2 Beza, there are electronic components in a car fit with a brake assist device to track the speed at which brake is applied. As the driver drives the vehicle, A small computer keeps track of how the driver usually applies the brakes, both how rapidly and how strongly, and learns what the basic pattern is. The last design of the Product Beza brake system is Advanced Safety Assist 2.0. A set of stereo cameras mounted on the ceiling of the Product Beza just behind the front windscreen is equipped with Advanced Safety Assist 2.0. These cameras play a very important part in the proper functioning of the ASA. The cameras send a live feed to computers after a detailed review of the feed and make certain choice and behave accordingly. I will continue to explain about the design of suspensions. The front suspension is using MacPherson suspensions. The MacPherson suspension system is commonly used in many modern vehicles due to its compact size, light weight, high durability, and good riding characteristics. With the assistance of a rotational joint, the control arm is attached to the chassis. The MacPherson suspension system's lower control arm and strut are joined by a spherical joint. Between the spring and the damper along the piston shaft, the strut and the chassis are placed to withstand shock and vibration caused by road bumps. The tight rod also ties the MacPherson suspension system strut with the assistance of the spherical joint, making this suspension system used in Product Beza, while the rear suspension is torsion beam. Due to various advantages, including reduced weight, reduced expenses, and compactness, torsion beam rear suspension systems are widely used for small passenger vehicles. These systems consist of two trailing arms interconnected by the basic arrangement of a flexible beam, in order to provide the torsional and bending stiffness needed for kinematic performance and compliance. Next is the design of the steering system. Our Product Beza was equipped with electric power steering. The electric control system which receives signals obtained by sensor for vehicle speed, steering angle, steering torque, and control the assistant motor to give the necessary assistant torque, is one of the most important parts of the electric power system. Last part of Product Beza design specification is design of the body system to meet crash safety. Product Beza is Product Malaysia newly introduced sedan brand. The result placed it under the 5-star category, but only variants with electronic stability control were awarded 5-star AOP due to the ASEAN NCAP 5-star requisite, while variants without the 4-star AOP rating were issued. In the category of child occupant security, Beza also performed extremely well, earning a 4-star ranking at 85% enforcement.
Hi, my name is Khalid bin Muhammad Nurisha. My metric number is MH19059 and I will continue with the product sketch. Our product sketch consists of isometric view, side view, top view, front view, and the rear view. The software I used to design the product sketch is the SolidWorks 2020. This is the isometric view of the car design. Notice that the car is facing toward the Z direction. We designed it with the consumer feedback of the previous model to help reach the targeted market. We designed it to follow aerodynamic shape as best as possible to reduce drag, which will be explained later. This is the side view of the car. It has minimum bend angle between each part of the body to promote better airflow. This is the top view of the car. The roof is slightly narrow than the body. This is the front side of the car. We designed it with large grille for better cooling performance, and we equipped it with LED headlamp which use less energy and produce less heat. It is also equipped with fog light to improve visibility of the short distance. This is the rear view of the car. It is equipped with the reflector to have better visibility of the car when it is parking at the dark place, especially at night. It is also has rear diffuser to help with aerodynamic, computational fluid dynamic. In automotive industry, CFD is used to understand the aerodynamic of the vehicle. Continue with the CFD cut plot. Cut plot is used to understand the air pressure around the car. The air pressure at the front grille is high, which is what we want because we want better cooling of the engine. We continue with the CFD surface plot. CFD surface plot is best to visualize about the air pressure on the body of the car. From the right side, you can see the air pressure is good. And at the front, we got a little bit high pressure. That is also what we wanted. Because for the cooling performance of the engine. So this is from the front view. Notice that the high pressure area is really at the grill, at the radiator of the car. So this is the top view of the car. This is the rear view. CFD flow trajectories. It will help you to understand about the movement of airflow around the car. Flow trajectories, isometric. So this is the isometric view of the air movement around the car. This is from the right side. You can see the air move. Here the air pressure is high, move towards upward and get back. This is the airflow of the car. This is from the top view. You can see it is equally spread to left and right and has minimum air pressure except at the right front and a little behind. So this is the front view of the flow trajectories. It has quite high, a little bit high pressure on the car, and it is low on the other side. This is from the rear view. You can see the air is a little bit swirl. CFD force. It is used to calculate the drag force and the down force of the car. Drag force is a force that acts parallel to the airflow, while the down force acts perpendicularly to the airflow. Improving down force without improving weight is preferred. Here you can see the graph of the force. The green line is the down force, while the orange line is the drag force. With SolidWorks, the both drag and down force is calculated with the iteration of 82. The down force achieved the criterion of 337 Newton and the average value is 296. The drag force achieved the criterion of 746 Newton with an average value of negative 3,310.
This is our flow chart. Okay, for the first one is selection of group member, and the next is selection of a car model, and then make rough sketches, and then gather information on selected car model, and next is 3D drawing. Next, we make a CFD analysis, and the last one is submission of our group report. Okay, this is our progress from the first week until the last week, which is week 13.
Now, I will continue to present about our cost productions. Our fixed cost total is 222,000 ringgit, including salary, office rental, insurance, repairs or maintenance, advertising, utilities, accounting charges and other expenses. While the variable cost total is 34,000 ringgit, including direct materials per unit, shipping per unit, another cost per unit and commission per unit. So the sales per unit is 49,980 ringgit. We decide the sales volume around 30 units, so the total of sales is 1,499,400 ringgit. Now, I will continue to explain our break-even analysis. So, the contribution margin is the sales per unit minus variable cost per unit. So, the sales per unit will be 49,980 ringgit minus 34,000 ringgit. So, the contribution margin that we will get is 15,980 ringgit. The break-even unit is total fixed cost divided by contribution margin. So, 222,000 divided by 15,980 ringgit, we will get around 14 unit. The gross profit ratio per period would be the revenue minus total cost divided by the revenue times 100. So, we will get around 82%. And the net profit is fixed cost plus variable cost minus gross profit, which is we will get 46,080 ringgit. Moving on to break-even. Break-even is a tool used to determine when a product will be profitable. The main purpose of the break-even point is to determine the minimum output that must be exceeded by a business to achieve profit. If the business does not meet this level, it will be hard for them to keep operating. As we can see, our break-even point will be at 14 units.
In conclusion, we have chosen the Beza 2020 car as an example in producing our company's new car. We choose this model because it fully meets our company needs based on design on safety features, which emphasize the production for long journey and provide comfort to passengers and drivers. The objective of our company is to produce an affordable high-power car. With these three main objectives, our company can compete with other local brands.
Okay, that's all from us. Thank you for watching and listening. Have a nice day.